Okay. Thank you, everybody, for coming today. You're either here because you are interested in performance testing REST APIs, or you maybe don't care about track A, evangelizing Selenium in your company. So my name is Jason Whedon. I am a quality engineer over at Constant Contact. And I wanted to put this together for you. It's kind of a hodgepodge of PowerPoint slides, the blog post, there's some code there. You guys deserve it. You know, you guys are the unsung heroes of your companies. Everybody's always beating you up regarding the fact that you're trying to break their stuff. Your bugs aren't really valid. You know, you guys deserve it. On another note, a lot of this stuff is framed with respect to lessons learned, but in all humility, definitely I'm willing to take a lot of constructive criticism as to you know, ways that we can do things better. Performance testing is a big arena. It is pretty daunting to try to tackle some of this, especially in the area of REST APIs within the context of a half an hour. But I tried to provide this smorgasbord of stuff for you that I think is really all related. So really quickly, let's start with digression. And that is a little bit more insight as to what we try to attack when we're talking about our REST APIs at Constant Contact. So if you go to developer.constantcontact.com, one of the things that we are really proud of is the fact that we have this awesome REST API developer portal that has all this fantastically detailed fields for your REST APIs, for your requests and your responses. We use this company called Mashery to manage our OAuth tokens, and you know, we're just psycho about the documentation. You know, you don't really see engineers really very detailed about documentation. You can talk to me afterwards if you're interested in learning more about kind of best practices for developer portals, but I like to think that we really nailed it, and if we didn't, we're gonna get there like tomorrow. We have a way to access actual API calls, so within minutes you're up and running with an OAuth token, and you can go into the website, hit get, and you'll see the responses below. So we'll do a live demo alert here. We'll try to see if we can do that here right now. Let's see if we could do that. Try it. And there it is. So I have request headers, response body. So if you're like not familiar with REST at all, and you want to just play around with some REST calls and kind of understand that within the context of a business domain, which is a small business marketing platform, which is what Constant Contact is, this is a great place to do that. Constant Contact is all about engaging these small business customers to be able to send these various campaigns that we call through the avenues of email, social media, help small businesses to really engage customers. You can create events for customers and whatnot. Okay, so that's the end of the fun digression. We'll have more digressions. So the problem domain here is that we're testing HTTP REST APIs. We're going to talk about hitting the REST APIs with concurrent connections. This is what happens in your production environments. So either GUI clients or third-party apps or partners. In our case, it's a lot of mobile apps and partners that are hitting our REST APIs at developer.constantcontact.com. And that's kind of what we're addressing today. So we're going to talk about defining your performance test approach, getting those results when they come in, sharing them, and kind of diving in a little bit into some examples of some good performance metrics. So lesson one, okay? So I said these are going to be framed in lessons. So lesson one is be dry. So what do I mean about that? What do I mean by that? Well, as good automation test engineers, you know the DRIVE principle, that don't repeat yourself, where when you're creating code, you don't want to duplicate the same code over and over again within a class, within a method, across classes. But I want you to take that principle and apply that across your different testing domains. So you have your functional tests and you have your performance tests. And so if you're creating a bunch of flows in your functional tests to do a get, a post, a put, or a delete, maybe even a patch or a head, why are you going into some third-party tool and recreating that same flow over again? So my bullets down at the bottom say that tools like Load, Runner, and JMeter do have their place. But I want you to think about your functional tests and parts of your functional test and how they can be applied to your performance test scenario. So you're going to be doing a get in your functional test, and you're going to be checking all sorts of things, right? So in your performance test, you're going to be doing that same kind of get, but you're going to be doing it concurrently. So I want you to hold that thought, and let's take a look at a Constant Contact tech blog post that I wrote. And this isn't going to show up the best, which is fine, because you can go by what I'm really talking about here. So on our tech blog, I have some sample code here, okay? And so if indeed you can see this, you'll see that there's two methods that are annotated with the at test annotation. So you know that as an annotation for test in test frameworks such as JUnit and TestNG. And so what this is doing is these tests are very, very similar, but one is ratcheting up the concurrency level up higher to 1,000 concurrency requests. The other is doing it for 1. And one is calling, let me get that back in line here. Get that back in there. One is calling a get person. So if you have a person object that you're getting, let's say it's a JSON object, and a person has a name, an email, and a telephone number, you can reuse the same client code. So we'll talk about what the client is in a moment. But in your performance test, you're going to do a get person and maybe just check response codes. Whereas in your functional test, you might do an unmarshal. And what we're talking about there is the fact that in your functional tests, when you do the unmarshal, what you're returning is not just a string, but you're returning an actual person object. So I know that when some people think about REST testing, they're like, oh, this is like what my browser does. And I can just grab an off-the-shelf HTTP client. We're going to talk about choosing HTTP clients in a moment. And so all I need to do is just throw some requests at it and get some string responses back and parse the string, and I'm good to go, right? No, please don't do that, okay? What I want you to do is put those responses in domain objects, also called DTOs, where it has all the getters and setters, so that you're returning an actual person. You've actually unmarshaled that into some kind of object, and so you're wrapping the response in an object, much like you wrap a Selenium page in a page object. So if we scroll down a little bit, we'll see that the person client extends a REST client. So these are different classes here, and this is Groovy code. The pseudocode that I'm showing you here is in Groovy, but applies to any object-oriented language because it's basically showing a pattern. But you get bonus points if you realize that my pseudocode compiles, which it does. And so we have a person client which extends from a REST client. So your REST client is going to do the raw get. It's going to call into your HTTP library to do the get. And your person client is going to extend from that, and that's going to be the one that deals with the whole person domain. It's going to have the person URL, and it's going to have all the get and post, put, and deletes on a person. And there's going to be some methods which marshal into an object, and there's going to be other methods that just return the string. Because when you're thinking about performance tests, you don't want to deal necessarily all the time with unmarshalling the response, because that can be pretty expensive. You can, but a lot of times it really falls into the auspices of functional testing, because you're testing to make sure that the payload has a certain format. But again, when you do that, even as a functional testing data point, you really are able to find a lot of errors just if you're not able to marshal the response correctly into an object. Let's go back to the presentation. So you have this concept of reusing these requests in your functional tests, in performance tests. And if you look at that third bullet there, one of the benefits of that is that you reuse your data seeding. So for example, if you have a REST endpoint that is all GET requests, because maybe it's like a reporting endpoint, right? So there's some data seeding that you have to do to be able to get all the data in there so you have stuff to get. And maybe your performance test is very specific. I need to do a get on something that has some amount of stuff in there that I need to get, or something that I need to paginate through. So your functional tests are going to have a lot of that data seeding logic in there. Again, why recreate the data seeding logic? Okay. So when we're talking about these third-party tools, LoadRunner, JMeter, there's some things to consider. They create blocking connections that reduce scalability. We're going to talk more about that. But for right now, think about blocking as one thread per connection. So for every get, you're using a thread. And so you're using up lots of resources if you're scaling out requests into the thousands or tens of thousands or more. We already talked about rewriting logic. And finally, if your tests are in Java, or maybe you're into Ruby or C#, hopefully you're writing in the same language as your developers. And therein, you really can share knowledge in your team, across teams, if you all have the same landing point, which is the same language that you're writing tests in. So lesson 2, choose carefully. So you don't just want to take an HTTP client that you know and love or used or heard about and just start writing up gets and posts, and you need to think about it very carefully, especially in terms of performance testing. HTTP clients have lots of features, and so you may need some kind of different feature that HTTP clients have. There are some HTTP clients that have this thing called spider support. Some providers such as Facebook and Google are supporting a different version of HTTP that's kind of off to the sides in the process of being standardized. There's lots of little things like that. In terms of performance testing, though, which are the bullet points up here, we're talking about non-blocking connections that allow you to scale up. We're in the JVM world in my team, and so when you're dealing with non-blocking connections, you can have a small amount of threads that are federated across thousands of connections. You don't necessarily have to map one thread per connection. When you have a tool like JMeter that is making those blocking calls, you are going to get to a point where when you get into the thousands of connections, the resources that are being hit on the client machine are going to affect your performance metrics. And so if you have a more scalable client that you can just as easily use in your functional tests, you can use that as your tool of choice to be able to use in your functional tests as well as your performance tests. So if you're on the JVM, you should definitely look at the Akka library. It's pretty cool. It comes from the Scala community, Scala being another language that compiles to JVM bytecode. And they have an awesome Java API. And one of the great things about it is that it scales across multiple processors. It prevents the need to deal with any of the shared states. So this threading stuff is difficult. You know, a lot of the later Java APIs make it a little bit better, but when you're having to deal with shared mutable state across threads, that's the thing you need to keep in. That's the thing you need to take into account when you're dealing with concurrency, shared mutable state. So if you're updating like a counter, some kind of performance metric that's across all the threads, you gotta make sure that that counter is able to deal with concurrent access, shared mutable state. If you're gonna deal with shared mutable state, you're gonna write it, and then you're gonna write it wrong, and then you're gonna eventually get it right, and that's after lots of conversations with people. Or maybe you're really smart and you get it right the first time. It's not easier to be smarter than me, but in the Akka world, you kind of have all that abstracted away from you. You're not dealing with a lot of this shared mutable state. In fact, you're not dealing with it at all. You're dealing with something called an actor model, which I don't have time to go into. But we're going to talk a little bit more about Akka in a little bit. There's some other examples on the JVM of non-blocking HTTP clients that I really, really like, that I think are pretty awesome. So these kind of were coming of age after some of the stuff that we had built out around the same time. So Sprays from the Scala community. That thing is a monster in a good way. It can really scale. The Jetty 9 seems really cool too. They're using a lot of the asynchronous non-blocking Java APIs, which they know really well, to do a lot of the same kind of stuff with the architecture. And then there's the Netty one too. So back to Akka. So what we ended up doing was we used the Apache HTTP client. Raise your hand if you're familiar with and maybe use the Apache HTTP client. Now, of the people that have raised their hands, keep your hand up. How many of you are sure that you know you're using the HTTP components HTTP client and not the deprecated one that is really old? So check that because you want to make sure that you're not using the old one. You want to use the new one. You don't want to use the deprecated one. So that was our tool of choice. So we use the Apache Commons math library to do some of the statistical analysis to deal with all the min-max, variance, percentile stuff. I'll show you that. So it's very high performance. Again, we have a programmatic API, so developers can go in and create performance tests, which they've done. Again, you're not wet. You are not repeating yourself. It's useful for our functional and our performance tests. And actually, for all of our functional tests, if you care about it or not, in the log, we're logging performance statistics on each and every request. It's just that on the performance tests, those metrics go into a database. So we'll talk about putting and persisting stuff in a database in a little bit. So it's been pretty good so far. It's been up for about a year. And in terms of threading problems, I've had 0 problems with the Akka framework in terms of having to deal with any kind of nasty concurrent threading problems. So we did some anecdotal tests. So when it had 8 threads going, in JMeter, it had 1,500 threads. So when you configure JMeter, you configure number of threads, which are the number of requests. And so it was just as fast, if not a little bit faster than JMeter in some of the anecdotal tests that we did. I'm not really interested that much in racing other tools. So I never did like real scientific tests on JMeter and LoadRunner, but all of our tests are in source control. We don't have any dependency on an expert in any commercial tool. So there's no toolsmiths that are kind of keeping all the performance knowledge to themselves, which is really important. And we can tweak it because we own the source. So we have lots of concurrency properties to tweak, for example, in the Akka properties file. So those are the first 2 lessons. Let's move on to lesson 3. Lesson 3 is devise a performance test plan. So you want to think about your SLA, right? So this can be a bone of contention in some places because people are like, where do I get my SLA? Shouldn't I just go in and start slamming that thing with tons of requests and have fun, and see what happens? But we're talking about like an overall testing approach, a testing strategy here. So you want an SLA, you want a service level agreement that at least defines average response times and requests per second for your various requests that are under test. So you can get that from historical data. There's lots of good tools out there now that will mine data and get you some information. There's API vendors that will amalgamate all that for you, as well as there's tools like Splunk that will go into your logs and help you do advanced queries. So that's the SLA. Second bullet, what kind of performance test? So you can do lots of different kinds of performance tests. So one is a profile of production performance. So what you need to keep in your head there is the fact that there's different kinds of requests going on at the same time. So you may have on a particular machine, within a second, there might be 10 posts, 5 gets, and 3 deletes. And so you're going to start writing your test case in such a way to model that. And so, maybe you take 6 months of data, the most recent 6 months, and you do some math on that to get down to, across all these different requests, what's exactly happening. Notice how I'm coming back to data seeding again. So, you set up your performance strategy, you're trying to fit it into these agile sprints. It's like, this testing stuff is hard enough as it is to fit into the 2 or the 3 week sprints, whatever you're doing. So one way to do that with performance testing is to say, you know what, I'm not going to do any testing in this sprint. I'm going to do data seeding in this sprint. You've got to take into account your data seeding, remember. So if you're going to do like a get or a delete or a put to update something or a patch to update something, you've got to have something there first. So you need to do your data seeding. And so that's often a good idea to have a sprint where you're working on data seeding, because you might need to write a whole bunch of code to do the kind of data seeding that you want that emulates data seeding in production. Okay, that might take a couple sprints. People are just going to have to deal with that. You're going to have to tell them that. But maybe a lot of times you do that kind of request, but you need to zero in on things. And so you may just want to do an X amount of gets. And this is often a very common test and a really good test to do, because developers know exactly what you're stressing when you're talking about one kind of request coming into the system. So one thing that you might end up thinking about there are server-side metrics. We'll talk a little bit about that. Longevity, you're running tests for a specific amount of time, and you're really seeing how the server responds. So you might just be concerned on the client side if you're getting any kind of errors, but really on the server side, you're checking for exceptions, any kind of error event, CPU memory, thread pooling, database connections open, monitoring all that good stuff. There's a lot of good tools out there that do that. New Relic is a really good one that we really like. So you need to think about what metrics you're going to be capturing on the client side and on the server side. So we talked a little bit about response time and requests per second. When we talk about persisting in a database, I'll dive a little bit deeper into the client metrics, but I mentioned some server metrics already. CPU memory, database connections, that kind of thing. In your performance test plan, second to last bullet, how will your results be captured? How will they be reported? Okay, so define this. Okay, have a document where you define this. You know, get a wiki up and running, right? Those things are great. You're not mailing around Word documents that get lost in people's Outlook folders. So you're going to say, this is what I'm going to capture, this is what I'm going to report, right? And then check out that last bullet. Have sign-offs on your performance test plan. Because when it comes to performance, people are like, oh, why didn't you test this way in this environment, using this thing and that knob on and that knob off, and can you do that? You know, and it's like, no, wait, you signed off on this initial strategy, and yes, I can do that, but let's do that in the next iteration. So that's why you want to sit in a quiet room, think about the details that are going to go into your performance plan, bounce that off of some performance experts, so that when you have all the details in there and they sign off, they will you know, kind of have an acknowledgement of, okay, this is what we're doing this time around, and then we can tweak that as we go along. Lesson 4, capture your performance test results in a database. So you want to capture your client and service statistics, as mentioned up there. On your response times, you can do things like percentiles, 95th percentile, 75th percentile. Maybe you have an SLA that says in the 95th percentile, my response time is 200 milliseconds for GET request to a person. For the server response, for the server-side metrics, you may have things like thread count, OpenDB connections, like I said, but you also might be doing some profiling. So there's profiling tools that allow you to dive in. We looked a little bit at Dynatrace there, which is another tool that does that. And so there might be some server-side profiling that you want to do, especially when you're trying to really characterize what layer in the application is slowing things down. And that can be done in the context of performance tests, and is often a good time to do that. You want to capture your test tool used and the version number, the test name, and description. You always want to have free-form comments, concurrency level, the environment that your test was performed, the server host names, when it was performed, the version of your test tool, and application under test, so you can go back and recreate. So in a database, you have things persisted for posterity, and you can then trend them. So you want to run your performance tests continuously, lesson 5. And so lobby for a dedicated performance environment. Run your tests in non-production CI environments, if only for training for relative measurement. So your CI environment might resemble of like a tenth of production. So you can do the math on that diff and figure out if that is still a valid number. But at least if you're doing it in your CI environment, you can see how the previous 5-10 runs went versus your current run. So maybe you're not looking for a specific SLA, but you're just kind of looking at the results from a relative perspective. And so you can hook it in your CI environment and therefore run it daily, even from a build server using Jenkins. And then you can create visualizations for your performance test results. So this is all about your business skills as a software tester. So you want to really think about in your test plan what kind of visualization you're going to have. And you should have a dashboard of performance metrics. Hopefully, this is something that people can go in and play with and filter on results and put in specific queries to see what they want. But you should also have email results to the relevant players after each performance task run. And the more visual, the better. But grids are nice to be able to zero in on stuff. We're looking at a bunch of different options. So I was just playing around with different options. So Splunk, normally used for log files, has the ability to go in and query a database. It's kind of this query language where you can go in and query your database and dynamically generate charts. And generating reporting from databases is a problem that's been solved like a million times over by every language out there. So there's lots of tools and libraries. But we're looking at a couple of other options as well. You know, I've just been playing with D3 just because I was kind of refreshing some of my JavaScript skills. So I can talk to you a little bit more about that afterwards. Show you the code really quickly. I know we have 4 minutes, and you're probably hungry. So if we're talking about the actor model, let's see here if I can make that bigger. So you have this concept called a future, okay? So think of the future as a container for your results whenever they come back, okay? So if you have a for loop that is bam, 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 sending out requests, they're not going each time through the loop, it's not going to wait for the request to go out and come back. The next, all the requests go out and come back. No. So this is what makes it concurrent in that the loop just goes right through, send, and you get immediately back a future. The future is not going to be the response, but it's going to be the response, or it's going to be waiting for a response. So you often have like some kind of wait in there where you're telling it how long you're going to wait for. And so you'll see that it uses a callback because Java does not yet have lambdas. So it's using like rather an inner class. So you're basically defining the method that you're going to be putting inside of your future. And I know we're a little bit time constrained here, but you'll notice that this do request work is the thing that is the work that's actually being done, which is right up here. And notice how this method is like super confined. Its only real line of code is doing your HTTP client.execute, which if you know the Apache framework, that's the one that actually sends the request out. Like it's actually going out on the line. So what's in your actor, that is the unit of work that's going to be whose response is going to be defined in the future. You are just putting a very, very small amount of code in. And so then that gets handed off to this response handler class, and there's a callback here that does a timestamp as soon as it gets back, so we can deal with response times. So if we were to look at, for example, what the log file looks like, waiting up to 300 seconds for 10 results, and it has all the results in the log here, standard deviation, requests per second. The Apache math library is great. I mean, you don't have to do any of this math, right? You're just throwing it all into like an array and saying, Apache, just give me, min, max, population variance. You don't have to even know what math is, right? So we have average requests per second, average response time as well is hidden in there somewhere. There it is. Average response time in number of milliseconds. And then we have assertions on the response code. And also some database inserts for the results. So that brings us up to, sorry, 1 minute before the end, but I am open to questions. Yes?
How do you separate your data setup to this actual performance test?
Yeah, so the data seeding setup could be in like an at before annotated method, or it can be in the at test method and it's just in the first part. These statistics are only looking at, they start ticking once the request is sent out on the line, and they stop ticking once the response comes back. So all the stuff that happens before and afterwards to set up the HTTP requests and to do the data seeding, or to do the database inserts is not part of the actual math for the statistics. And the other thing that we are very particular about is we don't do any logging while the requests are sent out, because we don't want I/O to interfere with any of the performance metrics as well. Any other questions? Yes?
Is this same approach used, for example, when you guys send out like last mailings and things like that, and you know, queues, queue tasks, and look downs, or?
Wow. Yeah, I mean, the concurrency models for that, I think, are in a completely different domain, a little bit outside of my ken. So I'm not sure how they do that. I think at a very high level, they're dealing with concurrency and making sure that things are sent out in a scalable way. But I don't know exactly how it's architected. Yep. Any other questions? It's OK. We can go over a minute if you want. Yes?
So first you showed the site that had your REST APIs.
Mm-hmm.
What was that?
Developer.constantcontact.com.
You don't have to sign up or anything. You can just go there.
Yeah, you're signing up for a Mastery account, which Mastery allows you to hit like a lot of different APIs. But then during the process, you're going to fill out like a quick form, and that will sign you up for just a free trial of a Constant Contact account. So you can just, you don't need your credit card or anything. And then you can hit the API and play with it. So it's really, really nice that way. I was going to say something else regarding that. In terms of URLs and slides and whatnot, so I tweeted that out at the SEConf handle, and they're up on SlideShare. Can show you where this stuff is. It's right here. Thank you very much, everybody.